everyone, today we are going to solve LeetCode 226, which is called Invert binary tree here, and it's an easy question. So we are going to do what it says. We are going to invert a binary tree. What invert means is that if we have a binary tree like this, we will have every left subtree of a node in its right hand side. So this 2, 1, 3 subtree, this subtree will come right here. And as you can see, 3 and 1 is also inverted. Then this subtree, 7, 6 and 9 is going to be here, and they are also inverted. So this problem was inspired by this original tweet, and there's a tweet of Max Howell. He says something like this, you can read it. So let's go and think about it. How can we do it? Actually, it's very straightforward. When we come to a node, we will just check if it has a left subtree, and then if it has a left subtree, we will put it on its right. And we will do the same thing for the right subtree, and we will go from top to bottom so that we can, when we go leaf nodes, we will know that we have handled all the cases. So let's just create a function for this, and let's make this function void, and let's call it Invert. Okay. What it will take is it will take a 3 node instance. Let's call that also root. And if this node, this root node, doesn't have a left child, and if it doesn't have a right child, then we will just return. We will do nothing because this is a leaf node, and we cannot invert a leaf node. Yeah. So after this point, let's define like 2 3 node instances. Let me call them L, representing left. This L is null at first. Okay. Actually, we do not need that. We do not need to do that one. We can make it root left, and if it is null, it's already null, right? We will do the same thing for the right hand side. Let me call that R, and this is going to be apparently right. And okay, so we have temporary instances of left subtree and right subtree. So if we have like left, then what we are going to do is, by the way, let's just nullify these pointers. Root left is null, and apparently root right, okay, root right is null. We did something like this. We took this node, for instance, and we kept this pointer in L, and we kept this pointer on R, and we just made all of these things null. So 4 is like alone right now. What we are going to do is, if we have a left subtree, this is our new right subtree, right? So what we are going to do is root right is going to become left. And in this case, if we have a left subtree, we will know that this becomes our right subtree, so we can make a recursive call here. Inverter, what we are going to call is root right, because that is existing for sure, because we know we had a left subtree, which means we have a right subtree right now. And some other thing, if we had a right subtree, we do the opposite thing here. So our left becomes previous right, and we just send our left to recursive call. So let's run this, but before, of course, we have to handle this inverted tree function. So if we do not have anything in root node, what we are going to return is null, right? Okay, we are going to return null because it's already null. Otherwise, what we are going to do is we are just going to run this function for the root node, inverter root, and then we are just going to return root itself, because that will have the updated version of the binary tree, the inverted version of binary tree. So let's see if this works. Apparently this works for this example, so let us change. Okay. Let's see if this works for this example. And yeah, let us submit. So our code works, and believe me, it's optimal solution. We just traverse all the array just once, all the binary tree. So yeah, thank you for watching.